All right, so for this notes, what we're going to do is we're going to compare linear functions to exponential functions. We know linear functions are y equals mx plus b, where the m is the slope and the b is your y-intercept. Now, in the functions you're going to learn today with exponentials, they're written like this: y equals a times b in parentheses raised to the x power. Now, a is so the a value is your y-intercept. And then the b value, this is going to tell you if it has a growth and decay, but that's just called our base term. Base just means whatever number is being raised to the exponent. So let's look at the linear one first because we should be familiar with it. So we've got 3x plus 2. First, we need to get our y-intercept. Well, it's this plus minus number right there. Y-intercept's at 0, 2. And then our domain, it goes to the left forever, it goes to the right forever, so that's going to be all real numbers. Our range, it goes down forever, it goes up forever, so that is also all real numbers. Now, on our exponential, our domain, look at it going to the left. Well, this arrow, it keeps going on forever. And boom, going on to the right, and that one's going on forever. So our domain is going to be all real numbers. Now, our range, if we look, it goes up forever, but when it's going down, there actually is a stop. Now, this right here is called, and this is going to be your new word today, it's called an asymptote. Sorry, A-S-Y-M P-T-O-T-E. Now, what asymptote literally means is it forever approaches a number, but it never crosses. Now, what you would see in a calculator is you would see the fraction getting smaller and smaller and smaller and never getting 0. So like this one is like 2/3, and that's like 1/3, and then this would be like 1/6, and this would be 1/7, and 1/8, and 1/9. And each one is getting smaller and smaller and smaller and smaller, but it never hits 0. So your asymptote is going to be at y equals 0. Our y-intercept, where it hits the y-axis, and you can just look at your a value. Your a value here was positive 2, so the intercept's at 0, 2. Our range, it goes up forever, but it never hits 0, so we're just comparing our y's to 0, and all the y's, they are bigger than 0. They never become negative, so it's greater than 0. Since it's an asymptote, it never crosses, so it's always just going to be the greater than or the less than symbol depending on your graph. Let's look at another one. Let's do the linear one first. The intercept, this one, well, it said plus 2, but it actually should say minus 2 because it hits at negative 2. So 0, negative 2. And our domain, it goes left forever, right forever, all real numbers. It goes down forever and up forever, so that's also all real numbers. Now, on this other graph, first, let's get our intercept, because that's just our a value. It's at negative 2, so intercept's at 0, negative 2. If that confused you, finding it from the a value, you can also look at your graph. It hits right there at 0, negative 2. Asymptote. Well, it goes down forever, but I look over and it looks like it never is going to hit that x-axis. So it's at y equals 0. Never hits that 0. Our domain, well, it goes to the left forever, it goes to the right forever. That's also going to be all real numbers. And our range, this time we're comparing our y's to 0, but our y values, because you compare your range to your asymptote, this time they're not above, they're below. So instead of greater than, it's going to be less than 0. So on exponentials, you're looking at two things. Look at the a value, that tells you your intercept, and then see where it approaches but never crosses, and that's your asymptote. Your domain is always all real numbers. Your range is going to be your y value comparing to whatever your asymptote was. Now, on the back of these notes, these are just some key things for us to remember. We're just going to kind of discuss them. For a linear function, your domain is always all real numbers. Your range is always all real numbers. For a parabola, a quadratic, domain is always all real numbers. Range is the y values either above 0 or touching 0. It's whatever the max or the min is. It's based on the parabola's vertex. You're comparing your y values to that y value in your vertex. Now, for an exponential, your domain is always going to be all real numbers. Your y's is going to be comparing it to your asymptote. So on this graph, the asymptote's at 0. It never hits 0. So it's going to be the y's are greater than 0 because they're above. And quadratic, they can open up or down. The domain is still going to be all real numbers. On this one, it said the minimum here was at -3, so the y values were greater than or equal to -3. On this one, our parabola opens down. Our domain is still all real numbers. Y values hit at the max, which is at +1, 2, so they are less than or equal to 2. On these exponentials, domain is still all real numbers. Anytime you get domain and range for exponentials, all real numbers for domain. The range, there's your y values to where the stop is. This one, it stops at, and it says it's at -1 because 0's there and it goes below 0 to -1. So the y value, since it's above, it's going to be greater than. Over here, it's going down, so it's going to be less than. And this one also approaches -1 and never hits it, so it's less than -1. Your domain, though, is still all real numbers. That is it for this page. We've got one more set of notes.